The rock was cold under my hand. Wind was screaming past my ears, and behind me I could hear tourists laughing, taking pictures, calling it beautiful, calling it strange, calling it a wonder of nature. But all I could do was stare up at the thing in front of me and feel that quiet, ugly tension you get when your eyes see something your brain is not ready to accept. Because the top was flat. Not rough like a broken mountain. Not sharp like a peak. Flat. Slightly hollow in the middle. Like something had been cut. The sign said it was a volcanic formation. A plug. An intrusion. A natural monument shaped by magma, time, pressure, erosion. Maybe. But standing there, with my palm against those long vertical columns, looking up at a giant tower rising out of the Wyoming plains, I had one thought I could not shake. It looked exactly like a tree stump. And not in a vague way. Not in a, maybe if you use your imagination way. I mean exactly. The vertical structure, the shape of the crown, the flat top, the debris around the base, the way it stood by itself like the center of something that had once been much larger. That was my first problem. The second problem was the number. 40 miles. That is the number some fringe researchers throw around when they talk about the idea that Earth may once have supported plant-like organisms so large that what we now call mountains might actually be their fossilized remains. 40 miles. 64 kilometers. It sounds insane. It sounds like the kind of thing you laugh at in the first 10 seconds and forget by the 11th. That is what I thought too. Until I kept looking. And once I started looking, I found the same shape again. And again. And again. So this is not a video asking you to believe something crazy because it sounds exciting. This is a video asking a much more uncomfortable question. What if some of the strangest things on Earth have never really been examined with the one question that matters most? I did not come to this theory as a believer. I came to it as a skeptic. A hard one. I thought the whole thing would fall apart the moment I started checking details. Usually that is what happens. A weird idea survives only as long as nobody asks it serious questions. But this one did something different. It got weaker in some places and stronger in others. It stopped looking like a clean theory and started looking like a pile of unanswered problems. And that is much harder to dismiss. Take Devil's Tower, for example. It rises out of the land almost alone. Massive. Vertical. Covered in long columns that look almost engineered. At the base, huge broken pieces of the same material lie scattered around it, like fragments that fell away over time. Officially, the explanation is simple. Magma pushed upward underground, cooled, hardened, and over millions of years the softer rock around it eroded away, leaving the harder core exposed. That is possible. I want to be clear about that. It is possible. But here is where the discomfort starts. Every official explanation works one piece at a time. The columns can be explained. The shape can be explained. The isolation can be explained. The broken material around the base can be explained. The problem is how perfectly all of those features together resemble something biological. That by itself is not proof. Of course it is not. Humans see patterns. We see faces in clouds. Animals in shadows. Meaning in random things. That is real. But pareidolia only explains quick impressions. It does not explain why certain formations across different parts of the world keep creating the same exact impression over and over again. Flat-topped forms. Circular bases. Vertical internal structure. Material scattered around the base as if it broke outward from a central mass. Shapes that resemble stumps, trunks, roots, fibers. At some point, you have to stop saying, That is just the human mind making connections, and start asking, why does the same connection keep showing up in the same kind of places? That question sent me backward into older geological notes. And that was where things got worse. Because some early surveyors and geologists did notice these comparisons. They wrote about rock that reminded them of wood, about internal patterns that felt oddly fibrous, about formations that looked less like broken mountains and more like something once living. They did not build a whole theory around it. They did not scream conspiracy. They just left those observations there, quietly, like uncomfortable fingerprints in the margins. Then the modern system did what modern systems often do. It absorbed the discomfort into normal language and moved on. Curiosity became metaphor. Metaphor became irrelevance. That should bother you. Not because old scientists were secretly hiding the truth, but because institutions are very good at protecting categories. Once something has been labeled, most people stop looking at it. The label does the seeing for them. Mountain, volcanic plug, basalt columns, erosion remnant, case closed. But what if the case was never really opened? Then I moved beyond Wyoming. I looked at Giant's Causeway in Northern Ireland. Tens of thousands of stone columns, many of them hexagonal, locked together with shocking regularity. The official explanation again is cooling lava. As the lava cools, it contracts and fractures into columns. That is real geology. The same kind of columns appear at Fingal's Cave in Scotland, at Svartafoss in Iceland, in Sicily, in Tasmania, in other places across the world. Again, I am not saying lava cannot do this. It clearly can. What bothered me was the repetition of the same structural language in so many places, and the way that language feels almost organic. Not alive. Not soft. But organized. Like a growth pattern turned to stone. And then the idea stopped being visual for me and became chemical. Because we already know organic material can become rock. Petrified wood exists. Entire fossil forests exist. Wood can be replaced by minerals over immense periods of time until it becomes stone while still preserving parts of its original structure. Under the right conditions, nature does not just destroy biology. Sometimes it records it. That changes everything. Because now the argument is no longer, could a living thing ever become stone? We know it can. The argument becomes, how large could that process scale before our imagination refuses to follow? Most people reject the idea of giant tree-like organisms not because they have tested it and found it false, but because the scale sounds offensive to common sense. It feels too big, too dramatic, too mythic. But chemistry does not care what feels mythic to us. If mineral replacement can preserve a branch, it can preserve a trunk. If it can preserve a trunk, then the only real limit is whether such an organism ever existed in the first place. And that leads to the oxygen problem. Hundreds of millions of years ago, Earth's atmosphere had much higher oxygen levels than today. Around 35%, according to many models. That world supported insects and arthropods far larger than what we see now. Gigantic dragonflies. Giant millipede-like creatures. Life operating under conditions very different from our own. So ask the next question. What was feeding that atmosphere? Oxygen does not appear by magic. It comes from photosynthesis. The standard answer is that ancient forests and swamp plants produced enough of it to create that high-oxygen world. And maybe they did. But when you read deeply enough into the numbers, you start to feel pressure. The models work, but they work hard. They demand extraordinary plant productivity across vast regions for very long periods. Again, that does not disprove the standard model. It just leaves a door open. And behind that door sits a question nobody respectable wants to touch. What if ancient photosynthetic life was not just more abundant than we imagine, but larger than we imagine? Not a little larger. Radically larger. That is where the 40-mile number enters the conversation. Not as proof. As speculation based on the scale some people think would be needed to explain certain atmospheric and geological patterns together. Do I believe there were literal trees 64 kilometers high? I do not know. But I know this. Once you say the sentence out loud, you immediately feel the social punishment attached to it. It sounds ridiculous. Career ending. Internet poisoned. The kind of claim that makes serious people leave the room. And that emotional reaction matters, because it tells you why almost nobody with credentials wants to be caught near the question. Not because they disproved it. Because touching it is expensive. Then I found the part of this whole story that hit me the hardest. The technology to test some of these formations more directly already exists. High-resolution internal imaging. Structural comparison. Microscopic analysis that can distinguish between crystalline volcanic organization and preserved organic patterning. We use advanced scanning on ancient ruins, on fossils, on buried chambers, on all kinds of things where internal structure matters. So why has the central question not been pushed harder on formations like these? Why do we not hear about major programs designed specifically to test whether the internal memory of these structures is purely igneous, or whether anything inside them suggests a biological origin that has been misclassified? Maybe some people have looked in limited ways. Maybe some local studies exist. But where is the serious institutional effort? Where is the high-profile attempt to kill the theory properly? Because that is what should happen if the idea is nonsense. You do not ignore nonsense forever. At some point, if it keeps attracting attention, you test it in the strongest possible way and end it. But that is not what seems to have happened. Instead, the theory lives in the shadows, which is the worst place for any idea to live. Not examined enough to die. Not supported enough to mature. Just floating there, feeding on anomaly, ridicule, and public fascination. Then there is Shiprock in New Mexico. If Devil's Tower looks like a stump, Shiprock looks like a central trunk with long stone arms reaching outward across the land. Officially, those are volcanic dikes, magma forced into cracks that later became exposed. Again, possible. But look at them long enough and you start seeing something root-like. Something spreading. Something branching in intention, if not in exact shape. I am careful with words like that. Intention is dangerous. Nature does not design with human purpose. But certain forms still trigger the same response because they follow structural logic we recognize from living systems. That is the pattern here. Not proof. Pattern. And patterns are not enough to rewrite science. But patterns are enough to justify investigation. That is the line I keep coming back to. Not belief. Investigation. Because once you strip away all the dramatic language, all the viral titles, all the weird internet energy around this topic, the real question is actually very simple. Have we truly tested some of these formations against the strongest possible alternative explanation? Or have we mostly assumed the answer because the official story already existed first? There is a difference between explained and sufficiently explained. A very big difference. A label is not a verdict. A plaque in a national park is not the end of inquiry. And a theory sounding strange is not the same as a theory being false. I think that is what kept me in this subject longer than I expected. Not the fantasy of ancient impossible trees, but the more human problem underneath it. How often do we stop looking because a category feels safe? How often does science, like every other institution, move forward not by asking every possible question, but by rewarding the questions that fit comfortably inside existing maps? That is not corruption. It is worse in a quieter way. It is inertia. And inertia can leave enormous things standing in plain sight for centuries while nobody asks the one question that would change everything. So where do I land after all this? Not where I expected. I am not here to tell you mountains are definitely tree stumps. I cannot say that honestly. I am also not comfortable laughing the idea away anymore, because I have seen too many shapes that repeat, too many geological explanations that solve one piece at a time without fully calming the whole picture, too many examples of organic material becoming stone, too much dependence on categories that may have been accepted before they were truly challenged. Maybe Devil's Tower is exactly what the textbooks say it is. Maybe Giant's Causeway is nothing more than beautiful volcanic geometry. Maybe Shiprock is only magma, pressure, fracture, and time. Maybe all of this can be settled in favor of standard geology the moment someone applies the right tools with enough seriousness. Good. Then do it. That is the point. Do it thoroughly, publicly, clearly, not with mockery, not with labels, not with the lazy confidence that comes from repeating what everyone already says. Look. Really look. Because if the answer is ordinary geology, then ordinary geology should be strong enough to survive a harder question. And if one day somebody scans deep into one of these formations and finds preserved structural evidence of something biological where we were promised only magma and stone, then this will not be a small correction. It will be one of the most disturbing discoveries we have ever made about the history of life on Earth. Not because it would mean the world was magical, because it would mean the world was once bigger than our imagination, and the evidence was standing in front of us the whole time. That is the part one cannot shake. Not the trees themselves. The possibility that their remains, if they were real, have been visible for generations, photographed by tourists, described by signs, explained by experts, and passed by millions of people who never had a reason to ask if they were looking at a mountain at all. Maybe we are. Maybe we are not. But until someone asks the question the hard way, with the right tools and the courage to risk sounding foolish, all we really have is a name. And sometimes a name is just the fastest way to stop thinking. So the next time you see a flat-topped stone giant rising alone out of the land, do not start by asking what it is called. Start by asking why it looks so familiar. Because if those ancient giants never existed, then we lose nothing by checking. But if they did, then we have spent a very long time walking among the stumps of a dead world and calling them mountains.